Hey guys, this is Akshat Madan and welcome back to a new video. And in this video, we'll be learning the builder design pattern in Python. So this design pattern is helpful whenever you want to build complex objects. Okay, so there you need this builder design pattern. So don't worry, let's take an example as usual. So let's say you are building a class or you are using OOP principles to build a computer class. Okay, class here means the programming language class. Okay, so computer has GPU, it has RAM, it has a case, and it has the storage, it has a graphics card, a lot of components, right? So if you have to define a computer as a class, as a model, then you can define like this, as you can see on the screen. Like I have this class computer, and inside this, I have defined in the constructor, I've defined some properties: CPU, okay, memory, storage, graphics card, motherboard, power supply, and the case. And initially, all of them are optional string, obviously, and by default, they are none. And I have this method which actually just prints the information about this computer. So can I define computer like this? You can. So now you think from the point of view of a computer builder, the person who is building the computer. You tell me, if you are building a computer for your child who is just 5 years old, not 5 years, but 10 years old. Okay. So for that kid, you will be building a very basic computer, right? i5 is enough. 8 GB RAM is enough. 256 GB SSD or the storage is enough. Graphics card, even if it is not there, it is okay, right? So that's a basic computer. So in that case, the values for your object parameters will be different. For these variables will be different. But let's say you are building a computer for a gamer. So for that person, 64 GB, 128 GB RAM might be good. Or GPU graphics card, 16 GB, 32 GB should be good. Okay. So for that person, these values are going to be quite different. Okay. And in this way, you can have many types of computers. So we can see that the object creation is going to be complex because based on the consumer, my object is going to get changed. Okay. Or how this object will be used in the future is going to get changed. So that's why we use this builder design pattern where you use a class to build another class, basically to build another object, to build objects. Okay, not class, to build objects. And you can modify, or I can say you can use functions to define or initialize the values of these parameters. Let's not get confused. So now below this, I'm going to define an abstract class. So this abstract class is called computer builder, and it has a constructor self.reset. Reset is going to just uh, reset the computer object that we have to again empty computer. Again, no parameter set, everything will be none. Okay, so this is a reset function. And then inside this abstract class, I have a property computer, which actually returns the computer object, sorry, the computer model that we have. Okay, computer model. So over here, result is equal to self.computer, and I'm going to reset it, and then I'm going to return the result, which is a computer class, computer model. Okay. And then as you can see, I have some abstract methods. These methods are going to be used to build this object in parts. Okay. So let's say for a gamer, your CPU is 128 GB RAM. Okay. So this function will be used for building the memory for like a gamer computer. It is going to be different. Okay. So like this, you use these methods to build your object in parts. Now let's go ahead and try to use this abstract class. First of all, for gamer. So I have defined a class gaming computer builder, and I'm using this abstract class computer builder. Okay. And over here, I'm now like actually implementing these functions. Okay. Implementing these abstract methods. So if I'm using the gaming computer builder, then for this person, when I'm trying to build the CPU, the computer, so self.computer, the same object that we have defined over here it is self.computer, right? Now I'm starting to build this object in parts. So self.computer.cpu should be initialized. When I call this build memory function, then memory should be initialized. When I call this storage function, the storage should be initialized. Like this, whenever I will be calling these functions, the values are going to get assigned, okay, in that object that we have. Which object? This self.computer object, which is empty in the constructor. Okay. So this is for gaming computer builder, and you can see the values are quite good. They're quite big. Okay. Now let's say we have another builder for office computer builder. Okay. So here we don't need i9, i5 should be good. So same function implementations, right? But the values are different over here. So whenever I'm building a computer for office usage, my values are going to be different. And again, I'm building the object in parts. Now let's say I'm building a budget computer. Okay. So here is that builder. For budget computer, my CPU can be AMD Ryzen 5600G, then 8 GB DDR4, then the storage, then this SSD, sorry, graphics card, then this motherboard, everything. Okay, so this is for budget computer. Then I'm having this class, computer director. Okay, so director class that orchestrates the building process. So this is the class which is going to be used to use this builder. So it is going to take a builder. Okay, so in the constructor, I'm taking a builder. So based on your requirement, you pass the correct builder. If you're trying to create an office computer, then pass the office computer builder so that these functions get used. If you're building a gaming computer, then pass the gaming computer builder so that these functions get used. Okay, so like this, we have this computer director, which takes a computer builder. You initialize it. If you want to change the builder, you use this function for changing the builder. And then if you want to build a basic computer or if you want to build a full computer, okay. In case of basic computer, you have you self.builder.build CPU, memory, storage, motherboard, power supply case, then dot computer. If you want to like a computer with all the components and you want to extend it, then you can use this full computer. Okay, in this case, you can have some more functions also for building a complete end-to-end computer like mouse, CPU, everything you want to add, then you can use this function. In our case, both the functions are quite doing the same thing. Now let's call the main function. So over here, what I'm doing in the def main function, I'm defining the objects of my builders. Then I'm creating an object of my director, and inside this you pass the correct builder. So I'm passing the gaming builder. So if you pass the gaming builder, then for this director will be used for building a gaming PC, right? As you can see, I'm building a gaming PC. If you want to build an office computer, then you can use the change builder function, change it to office builder, and then you use the basic computer function. If you want to use a budget computer, change the builder, then build the basic computer. Okay. Then I'm having this for like if you want to like chain the methods, like if you want to call them on your own without using a director, then you can do it like this. So it is quite easy. I mean, you just have to understand what is this builder design pattern, where and where it is used. Otherwise, the implementation is super easy. And yeah, that's it. I mean, I hope you like this video. If you want, I can provide you the link of this code piece, a complete file as a GitHub gist. You'll find the link in the description. Till the next video, keep coding, keep innovating, and thanks a lot.